Hello everyone. In this video, I'm going to go over trigonometric substitution for the integral of x cubed, and then it's a square root of x squared plus 36. Now, we have three cases for trigonometric substitution. Case number one is whenever you have a root that looks kind of like this. So there is a number and then minus x squared. And the number usually is a nice square, but doesn't have to be. In this case, the substitution is a sine theta. And it is kind of a weird substitution because we're not saying u equals something of x. In this case, we're actually saying x equals something of theta. Okay, and then we have case two. That one is easiest to detect because you're going to have a square root and then x squared and a squared are going to be added, right? So whenever you see a plus sign, that means it's going to be case two, and your x here is going to be a tangent theta. Finally, for case three, the difference is we're also subtracting just like in case one, but we're actually going to start with x and subtract the number. In this case, the substitution is a secant theta. Okay, so looking at my example, I have to just focus on the root, right? That's all I'm looking at. And I'm determining which case do I have. Now, because I have a plus sign, that means I have case two. Okay, so if it's case two, that means my substitution is going to be a tangent theta. But what is a? Here you need to ask yourself, what squared is 36? So the answer is going to be that's 6. And that means your substitution is going to be 6 tangent theta. So we're going to type that here. Now, in these problems, trigonometric substitution, what you need to do is express everything in terms of theta. So you are translating from the x language into theta language. Just like with regular languages, like you're translating from English to Spanish, you need to translate every word, right? You can't just translate part of it. Okay, so what's going to happen here? What we want is x cubed and then square root of x squared plus 36 dx. We want to convert everything in terms of theta. Okay, let's look at what happens when x is cubed. Now, because 6 tangent theta is going to be cubed, that means the 6 will be cubed, which by the way is 216, but I'm just going to say 6 cubed, and also tangent will be cubed. So remember that both will be raised to the power 3. Now, what about dx? So dx is differential, but it's really derivative multiplied by d theta. Well, hopefully you remember that 6 tangent theta derivative, first of all, 6 we keep because it's a constant multiple, and derivative of tangent theta is secant squared theta. And then we also have d theta. Okay, so what's what here? So dx is translated into this new language and becomes 6 secant squared theta. X cubed became 6 cubed tangent cubed. But what about that square root of x squared plus 36? What will happen to that? Well, here you have to show me detailed work of what happens to the square root. And the reason why this substitution is going to be tangent is because this root we will be able to simplify it, okay? Because otherwise, if you tried something like sine or secant, this root will not be simplifiable. Let me show you why. Okay, so x squared, well, 6 tangent theta, you are squaring that, you're going to get 36 tangent squared. So remember to square the number and also square the tangent. Plus 36. And notice something, both of these share a 36, which means that you can factor it out. And then you're going to wind up with tangent squared plus 1. Now, this is one of those trigonometric identities that you must memorize. You've got sine squared plus cosine squared equal 1. That's one of them. But there is another one which says that tangent squared plus 1 is secant squared. And that's what I'm going to use here. Because if at this point this wasn't tangent, if it was something like sine squared plus 1 is not simplifiable, so it wouldn't work. Or if it was secant, well, secant squared plus 1 also doesn't work. But tangent squared plus 1 does work, and that gives you secant squared. And then the last step to simplify the square root is to actually take the square root, which is going to be 6 secant theta. So this root, we just translated to our theta language, and it became 6 secant theta. Now let's put all of this together. What we got now is 6 actually occurred 5 times, 6 cubed, and then again 6 and another 6. So that is 6 to the power 5. And then we get tangent cubed, secant cubed. Okay? And that is what we are going to type in here. This is called step 1 of the trigonometric substitution, meaning that you have to convert everything in terms of theta only. Okay? That's like translating English into Spanish. You translated everything. Notice how you started with 6 tangent, but the root became 6 secant. This is not, just a weird coincidence in this case. It's always going to happen. If you start with 6 tangent, the square root becomes 6 secant. If you start with 6 secant, the square root becomes 6 tangent. So you might want to just remember that. Okay. Now, the next step is actually step 2 that I don't ask in here because this problem just becomes so long that's too long. Okay, so I actually give my students the answer to that part and then ask them to finish it. But this integral, except 6 to the power 5, as a standalone problem, you will see that on my test. And that's why I am going to go over it and show you why this is the case. Okay, how do you handle some integrals like that? Well, the way you do that is you try, and sometimes it doesn't work, but we could try. You concentrate on the power of secant. If the power is odd, you should try a substitution secant. Now, this is going to be super confusing because it's now a regular substitution, but okay. Well, if I use the substitution secant, then this is going to become secant tangent, right? du. And what I do is, let me take out the 6 to the 5, because that's just going to stay there. I'm going to set aside one tangent and one secant. Okay, pluck them out. And so if I set it aside, why am I going to set it aside? Because that's going to be absorbed into du, right? Because this right here, that is just du. And then one of the tangents got split, so now you only have tangent squared. And then one secant got split, and now you have secant squared. Okay, now what do I do next? Well, the substitution is secant, so it is very easy to see that secant squared is just going to become u squared. But what about the tangent squared? U was secant. How do I change the tangent? Well, again, we go back to that identity that everyone needs to know, which is tangent squared plus 1 equal to secant squared. And I can now express tangent squared in terms of secant squared minus 1, right? So it's going to become secant squared minus 1. And because u was secant, I wind up with u squared minus 1. Now, how do I integrate something like that? Well, I'm going to distribute the u squared to both terms. This is going to become u to the power 4 minus u squared. Then I'm going to integrate, which is pretty easy because this integral is just, regular power rule. This is going to become 1/5 u to the 5, and then minus 1/3 u to the 3 plus c. And the last step here is to actually substitute the u, which was secant. So this becomes secant to the 5, and then this guy becomes secant cubed. Okay, so hopefully you see that what I just did actually matches to what is in here. So that step, what I just did, could be a standalone problem, but I'm not going to ask it as part of trig substitution because the problem just becomes so huge. Okay, so let's just say that this is what I got. Now I have to finish it up. How do I do that? Well, here we have to know or recall the right triangle trigonometry. And we have to remember our rule, which is called SOHCAHTOA. I hope I'm pronouncing it right. Okay, so here is angle theta. All right, just to make sure what is what in the triangle. We've got two legs, two short legs, and a hypotenuse. So the hypotenuse is right here. The side that's close to theta is denoted by A, so that's adjacent side, and the side that's opposite of theta is opposite, O, right? Okay, So what we're trying to do is now we have to go back because now we got the answer. So it's just like imagine you spoke something in English, they translated it into Spanish, right? Somebody answered and got this. But now you have to translate it back to English because remember we started with an integral that had x. So we want to translate this integral back to x. Okay, now how do we do that? Well, we see the secant theta, and actually it's raised to the power 5, and it's also raised to the power 3. But what is that in terms of x? Now, what do we know? We know they told us in the beginning, well, actually we said, that x equals 6 tangent theta. Let's divide both sides by 6. So we're going to divide here, we're going to divide here. What are we going to get? We get x divided by 6 equals tangent theta. Okay? Now, from our Sohcahtoa rule, we're using this part. That tells you that tangent is opposite side divided by adjacent side. So here's tangent. This is opposite side divided by adjacent side. What does that mean? It means that opposite side is x, and it means that adjacent side is 6. So now we can go ahead and figure it out. So this particular part, the A, that's your adjacent side. So that's going to be 6. The opposite side is going to be x. And what about the hypotenuse? Well, the other side, the one that's missing from the triangle, so we already know that this is going to be 6, and we know that this is going to be x. The other side has to match the root that appeared in the question. The square root, that was x squared plus 36 square root, that should be the other side you didn't mark. In other words, this part should be x squared plus 36. But why is that true? Well, because you have something called Pythagorean theorem, right? And the Pythagorean theorem says that if you square one leg, so that's 6 squared, plus the other one, that's x squared, that should be squared of the other side, and the other side becomes x squared plus 36 squared. Well, you have to take the square root to get the actual side, right? So we mark the triangle, okay? All right, so let me just go ahead and erase some of this because this is kind of confusing. So this is going to be 6, this is going to be x, and this is going to be square root of x squared plus 36. And what we need to do is we need to convert the secant that I see here and also here back to x. How do I do that? Well, what is secant theta? Secant theta is one of those trigonometric functions that you need to know how to relate to sine or cosine. And the most common mistake people make is that they don't remember, is it 1 over cosine or is it 1 over sine? Just remember that the first letter switches. If you started with S, so if you started with this right here, this should be the other letter. So that should be C, okay? Now, what was cosine? Well, from this, cosine is adjacent side over hypotenuse. But secant is 1 over that. So instead of adjacent over hypotenuse, you're going to flip them and it becomes hypotenuse over adjacent. So this is going to be hypotenuse over adjacent. Okay, we're almost done, I promise. Okay, so we're going to get 6 to the 5 over 5. Then the secant will be raised to the power 5, right? I'm just rewriting it so that it's easier to see what's going to happen. Then this is 6 to the 5 over 3. And then secant is going to be cubed. Now, instead of secant, because now you have to do the translation back to English, right? Back to x. Secant is hypotenuse over adjacent side. So what's hypotenuse? The square root. So we're going to put the square root here over the adjacent side, which is 6, and we're going to raise that to the power 5. And this is going to be 6 to the power 5 over 5. Okay, minus, this becomes 6 to the power 5 over 3. And again, secant is the same thing, square root of x squared plus 36 divided by 6, and we cube that. Okay, now, I want you to notice a couple of simplifications that we should make before we type the final answer. When a fraction is raised to the power 5, this really means that both things are raised to the power 5. So you're going to have the square root that is going to be raised to the power 5, and also the 6 will be raised to the power 5. And notice how this and this is going to cancel. Okay? The other one, well, you're going to get 6 to to the power 5 divided by 3. Then the square root is going to be raised to the power 3. And 6 is going to be raised to the power 3. So we can actually simplify it also, because 6 to the power 5 divided by 6 to the power 3 is 6 to the power 2, because you subtract the powers, the exponents, right? So, okay, so what that means is the first term is going to be 1 over 5. This 5 is still on the bottom. Then the square root is going to be raised to the power 5. And 6 squared is 36 divided by 3. I think that's 12. And then we're going to get the square root raised to the power 3. Okay, isn't that fun? Ooh, it only took me 45 minutes. Well, maybe not 45, but pretty much. That's what these problems are. That's why I don't ask step 2, because, man, just typing this just make me hurt. And a lot of times the books will factor the cube and simplify and everything, but I think this should work. Yay.